Well, thank you all for the opportunity to be here, and I'm quite honored and humbled to be with you all in light of what we're celebrating today. And wanted to talk to you a little bit about some of the perspectives that we look at, sort of broadly, also specifically, and as they apply to bringing new technologies to new markets. One of the common themes I've heard today that comes out quite frequently in the previous speakers has been not only the opportunities that present themselves in the global nuclear enterprise, but also the mandate and imperative to innovate. Now, I kind of take issue with that word because I think it's overly used, but I'll talk a little bit about why that actually is important. So I first visited the CP-1 site almost 12 years ago. My sister-in-law had gone to the University of Chicago, actually lived in the same dorm that Enrico Fermi lived in, albeit many years apart, and visited them on a trip to Chicago. They took me to the site, and for a kid from New Mexico who's been fascinated by nuclear history for as long as I can remember, it was quite a captivating experience. I couldn't help but be awed in light of the resourcefulness, ingenuity, and just general determination that Enrico Fermi and his colleagues exhibited in bringing that together, and especially considering the timeline and global circumstances. I was also struck by the fact that it's just another example that all great things really do start in garages and basements. Nuclear energy is no different, and that's a very important box to be able to check when you're in Silicon Valley. And in putting these comments together and kind of preparing for today, one of the things that struck me was thinking about how Enrico Fermi and his colleagues would think about the nuclear enterprise today and the future we face. And my thought that I came to after kind of rattling over this for a while was they would be quite encouraged about the bright future that's ahead of us. Now that might seem counterintuitive, especially in light of some of the comments and the realities that are going on today. And this isn't blind to the challenges we face. There are numerous challenges we face, highlighted, I think, most importantly by severe market distortions. It doesn't make sense when wholesale prices are clearing at about 3 cents a kilowatt hour or less, yet retail rates are 20 cents a kilowatt hour. Tim mentioned this earlier to some degree, but we have to fix that. That's not just for nuclear, that's for us as ratepayers and consumers. And I think there's good action going on there, but it's a huge challenge that faces not just the existing fleet, but deployments of new technologies. And that's compounded by the ebb and flow of funding that comes from fickle government programs and investments. It's just inherent. Similarly, regulatory creep and overreach has led to significant challenges for the existing fleet. I find it interesting when you think about the fact that we've already achieved phenomenal safety characteristics. You need a thriving industry to keep a regulator busy, otherwise sometimes they start looking and diving in places that just add to difficulties without really increasing or improving returns on investment there. And I think, unfortunately, this has led to a broad acceptance in the industry of a culture that we can't really do things. That's not true, and I'm hoping today to start to tilt that a little bit and explain why we can. And despite all of that, and the news that's come out recently, and sort of a dearth of good news in some cases as you look at the industry, at least domestically, we have to think broader. We have to think a little bit outside of what we're used to hearing in sort of a near-term sense. The global demand for nuclear is strong. The global markets are stronger than ever. Kunmo alluded to this, but the opportunities are huge there. We're seeing a broad global embrace of nuclear, even if some countries are either lagging behind or just staying stagnant. It's happening, and it's happening without us or with us. It will continue to, and we need to make sure that we can keep that leadership role that we've built, that we've maintained, but we're at risk of losing. And I think it hits on one of the key advantages that I'll talk about a little bit later, but it is our ability that as a country we have this diverse ecosystem of new companies, new ideas, robust technical culture at the national laboratories that can all work together to help us realize the true potential of these technologies. So one of the things that strikes me is the way conditions are changing globally for nuclear. We're embracing it globally. I say we as kind of a collective in light of climate concerns, security considerations, reliability considerations, which is starting to catch on, and frankly, when you look at the developing world, just plain demand for energy. There are huge opportunities out there. They extend far beyond our borders, and it's something that we need to keep our eyes on. And there's also a changing tide in terms of support and perceptions of nuclear. A lot of traditional organizations who used to oppose it are now starting to come around in the face of climate considerations and concerns, and also just coming to terms and realizing the benefits that come with nuclear. And I think that's an encouraging piece. It's a wind at our back in some cases, and we need to take advantage of that and keep building that case. Similarly, and I think perhaps one of the key underpins here in terms of why there is a bright future is really the game-changing innovations that are going on in the United States, both in our private industry as well as our national laboratories, that are really changing the way nuclear power can enter new markets. And it changes the way we've approached nuclear fundamentally. I think this is one of the hardest things that we're facing right now. We're no longer going to be a single government top-down led approach to nuclear. That has not worked well, and it won't work well going forward in the modern economy. In fact, we need to unleash and sort of unlock the potential that exists, especially in this ecosystem that's emerging of new ventures and creative innovation that's going on in big companies to small companies alike. And what this does is really start to tap into brand new markets that we haven't necessarily had the opportunity to have. So what does that kind of mean? When I was putting this together, I thought about the talk in the sense of what are the new markets? Well, it's quite an apropos title for what we do at Oklo, building a very small reactor, about 2 megawatts electric, that's aimed at providing power to off-grid and remote areas that are generally underserved and frankly have been unserved by nuclear. Nuclear is a fantastic power source in these areas that are reliant upon diesel fuel because nuclear wins in energy density by 6 orders of magnitude. That helps, but it also struck me in doing this that the new markets actually play much broader than that. It's not just remote or off-grid or international, it's also the markets here at home. Because the electric markets have changed dramatically in the last 15 years. We, as consumers of power, interact with the electrons we buy in a fundamentally different way than we ever did before. It's no longer as fungible as it used to be. We care more, and we see this at different levels, at different demographics, different communities, different geographies care more about where their electrons come from. They care about how affordable it is, how clean it is, starting to care about how reliable it is. And those are pieces that I think are phenomenally important for us to adapt to accordingly. The markets are changing and adapting. There are distortions. They've overcorrected or undercorrected, depending on which way they've gone in certain cases, but those will generally self-adjust. And we, though, as an industry, have to be able to understand what that means. Because when you see these adaptations happen, when you see small communities wanting to run their own co-ops they want to have their own power plants because they want to be decarbonized, they might want to own their own nuclear power plants, for example. It opens up the opportunity to think of skyscrapers siting nuclear power plants in their basements. You start to get into a broad variety depending on how the future of the grid will look, which is generally hard to predict, but it will be quite diverse and various, that we as an industry must be able to adapt to that and meet those needs. And we cannot do that with business as usual, which is generally a slow pace of change and innovation. And I think one of the key things that really underpins this is also how we think about the economics. One of the challenges that comes with the perspective of these new markets is understanding how we as a nuclear enterprise can deliver the cost effectiveness that we have the potential to do. And I think one of the things that really sticks out to me is the fact that we're going to start seeing value attribution. We've already started seeing it in existing markets for what nuclear can provide. And I think that's only going to increase as the grids become, the electric market, I should say, becomes more granular. I say that with some caution because I'm not necessarily advocating for high granularity in the markets, but appropriate granularity to reflect what consumers want. And what comes with that is the mentality of how we approach costs and what the true potential of nuclear power can be from an economic perspective. Sadly, in this country, we've seen some huge cost overruns. We look overseas at the UAE, you see projects coming delivered on time and under budget, very attractive cost numbers. I think we can achieve those same things because we have a truly competitive advantage on the global landscape when it comes to other energy sources and what we compete with. This is just taken from yesterday's spot prices on markets, but it's important to keep this in mind. Natural gas yesterday, spot price was about $3.11 per million BTU. Coal ranges, depending where you get it, of course, but 67 cents to $2.17 per million BTU. Uranium in a nominal LWR based on yesterday's prices is about 60 cents per million BTU. And when we look at the future of what we can do with nuclear, what we can unlock with technology that was developed at this lab and demonstrated with fast reactors, that cost can drop by several orders of magnitude. And then you go on, that's where you get this $0.0005 per million BTU. That's a huge advantage over everything else. It's completely unfair. And things that usually have an order of magnitude or more disruption typically win the day. So this is why I have a lot of hope that we can win here. And then even going up to a slightly higher number by an order of magnitude, still far more competitive, is the nominal pricing of a limitless or near limitless source of energy just using uranium from seawater in a fast closed cycle system. So this is why I think the future is so great here. But this is just the fuel cost, and I understand that. So let's kind of look into the capital costs. When you look at what the actual resource uses are for large power plants in terms of tons per terawatt hour generated, including their fuels, mind you, you see a similar trend. So why is it that nuclear's gotten so expensive? Well, unfortunately, I think we've accepted a culture that it has to be expensive. It's funny how I would be reprimanded by professors or by others by questioning why nuclear had to be expensive. Why do we have that mentality? We really shouldn't have that, frankly. And I think it's rather strange. We need to embrace this mentality that we have the potential to optimize and build nuclear power plants at costs that far exceed everything else. The physics are on our side, just we're in our own way. We shouldn't be in this mentality where we just accept things to be truly expensive. Now, I think there's an often tendency to say, well, nuclear's special or nuclear's different. It is not really that different or special compared to other industries that have really mastered supply chain and deployment in a vertical integration manner. It is special because of what it can do, but it doesn't need to be treated with these kid gloves that it always has to be more expensive. We as an industry have to drive this in a very favorable way and take advantage of the inherent advantages that we really have here. I think fundamentally that we, as a nuclear enterprise, or the various advanced reactors that are being developed and pursued, have the potential to achieve costs that are less than $2 a watt, so $2,000 a kilowatt. I think we can substantially beat that. And when you look at broad market studies, which of course assumptions are somewhat tendered, but just based on sort of current market conditions with some forecasting in the future about price drops of competing technologies, if we can deliver nuclear plants in the US between $2,200 and $2,500 a kilowatt, you can displace all fossil fuel by outcompeting it in 27 years. That's the fundamental way you drive deep decarbonization, but also lower the rates. Is this going to be easy? Absolutely not. It's going to be quite hard. It's going to be quite challenging, but it's completely doable. And I think, again, there's some technologies being pursued can really beat that cost number substantially. One of the other pieces that kind of falls from what happens with this is also on the global scale. Now, this is focused on the US, but of course, if we can achieve this on a broad global scale, you have a similar result where you can own a market that is nominally anticipated to receive about $48 trillion in investment. That's $48 trillion in investment over the next 20 years to 30 years in new generation technology across the world. We can have a huge piece of that, and we can drive that with new and better nuclear technologies that have the right cost and schedule management that I really do believe the technologies being developed today that are in some cases fairly mature and others that will be a little further down the road but are being enabled by fundamental new innovations can actually hit these kinds of numbers. Which brings up the question of global markets, which is more than just a question ultimately of cost too. Because as I said earlier, there is becoming an attribution of value to the different characteristics and capabilities that nuclear provides. One of the great ones of that, of course, is fuel security. Being able to load up a core with, in some cases, decades worth of fuel without having to refuel offers a lot of potential for certain developing areas. Also, the way the electric grid is coming into some of these developing markets is quite different. It's not going to look like the grid we've built over the last 100 years here. It's going to be a collection of microgrids loosely connected, which is opening up a totally different demand case for different sizes and technologies from what the typical nuclear enterprise product has been. It's no longer going to just be a 1 gigawatt type reactor. Instead, it's going to range from literally megawatts or less to gigawatts. This is one of the unique capabilities that nuclear has and a technological advantage because of the energy density packed in the fuel. And we're starting to see this materialize in the spectrum of technologies being offered and being pursued on the U.S. private industry. But this is one of the keys to actually tackling what's happening, especially on the blue line, which is really driving the growth here. And again, mind you, that is a massive opportunity. One of the things that kind of strikes me when we talk about these opportunities or pieces, and then also how, as a small company or a startup, as Oklo as we are you going to be able to even compete at these levels? Especially as the common complaint is we have to compete against Russia and China, or whatever state-owned or backed enterprise you might want to pick. I kind of like that. I like that for a couple of reasons. One, it motivates me because often, and it motivates our team, it's often to find this sort of question, well, if you're going to be successful, you're going to have to look like the big players do now, and how are you going to do that? It takes so much money and time and people, how are you going to do that? Well, the same criticisms were levied at guys like Steve Jobs and Steve Wozniak and Bill Gates. Look where we are today, by the IBMs of the world, I should say, and look where we are today. Similarly, and perhaps because some will dismiss that as being a technology specific and that's different than nuclear, Musk and the SpaceX team faced a similar criticism from the aerospace industry. How could you possibly deliver or compete with, NASA or the big aerospace players? And they've delivered launch costs that are 90% less than what they thought could be done. That's possible in nuclear too. In fact, it's probably more possible because we have this huge benefit in resource efficiency, both in energy density of the fuel, but also the materials. So the way in which business has been done will not be the way things will be going forward. And in that vein, or in that manner, that's one of the key competitive advantages we have in this country. We have this diversity of companies that are privately backed and building public-private partnerships with the labs that are pursuing a variety of technologies. They're able to move fast, they're able to test things, try them, fail, succeed, and move on depending on which direction they're going. That's really important because that's not the case almost anywhere else, this kind of vibrant ecosystem. It's new to us. It's new to the way the nuclear enterprise in the US has pursued things, but we have to start to embrace it and come to terms with what that really looks like. And I think it also means a change in paradigms of how we've approached the idea of public-private partnerships. Because when you combine the private sector innovation and the speed and pace at which it can go with the national capabilities and world-class technical excellence at the national laboratories, you have a pretty potent combination. But we have to think of public-private partnerships in quite a different way than I think the pervasive mentality in the industry is. This doesn't win me many friends in industry, but public-private partnerships aren't just about dumping cash into companies. It's a lot more than that. It's about building relationships with the labs, with the people at the labs, with the facilities at the labs, and pursuing problems together and building on the specific capabilities that the labs have, pulling innovations out of the labs, working effectively and efficiently with that capability set that's unique to this country. We also need to grow that. We had some conversation about a fast test reactor or a versatile neutron source. Those are the kind of investments that we need to make. You look at what the success of the advanced photon source has had in terms of material science and capabilities as a user facility in this country. Similar things will fall out from the investments in a fast test reactor. And that's just sort of the tip of the iceberg of stimulating a whole set of new innovation. The other piece that I think is important to talk about too is how the education system fuels both of those kind of top boxes. That said, the education system is a little bit behind. We need to improve how we're training our students. They're not really being prepared to contribute into what the nuclear enterprise or the economy, the innovation economy, if you will, of the future is going to look like. In some cases, you need to modernize curriculums. In some cases, you just fundamentally need to train professors to catch up on what's actually going on. But those are pieces that really need to shift. And you also need to change the mentality that's in the educational system. We don't need to have advanced degrees to be technical leaders. Warren Nyer is a perfect example of that. In fact, as you build a thriving industry, we need to come to terms with something that's incredibly uncomfortable for nuclear engineers. In fact, most engineers outside of computer science and electrical engineering is, do you even need a degree to compete in this space? And as we have a thriving industry, as we realize the potential that we have up here, the idea of the timing is now is going to become ever more prevalent. And what that means is people might leave school, might drop out of undergrad to pursue careers because the timing is now. That's starting to happen, and it's very uncomfortable, but we need to start embracing that mentality and fundamentally modernizing how we approach training students so that they're prepared to do that. And I'm not advocating for everyone to drop out of college, but advocating for people to be ready to be able to actually contribute meaningfully and really drive this forward at a very fast pace. And finally, I might get thrown tomatoes up for saying this, but we're blessed to have the NRC. Okay, a little laugh and chuckle. I think as an industry, we way too often look at challenges and not opportunities. Excuse me, when it comes to the existing fleet, there are definite challenges. We need to manage regulatory creep and overreach. But when it comes to new technologies, the NRC is the world leader in what it can do. It may not seem like that. There's this often tendency to want to run abroad. People often, I think, do that prematurely. Because when you really look at what the capabilities are in the NRC, particularly how they've responded in the last 2 years to the criticisms that were levied at them, some rightfully so, some not so much, they've adapted. And what they bring to that, to be ready to license these new technologies, is a global world-class pedigree and credibility that comes with that on the global sales arena. You see Korea pursuing a design certification in the US because they know how valuable that is in the global export. We have that baked into our own domestic markets. We need to use that to our advantage and work with them actively, both industry, the labs, and education system, to keep them both prepared, but also ahead, and as able to be ahead as they can be, I should say, of the innovation cycles going forward with new technologies. And I can say this, having several friends who work in aerospace and the FDA, I will take the NRC every day of the week and twice on Sunday over the FDA or the FAA, because they're actually way more geared to deal with new enterprises, new ideas, and new startups that are fundamentally rooted in good, sound engineering. You don't have this big, entrenched regulatory regime that's dominated by the big players. That's an important value that we have in the NRC that we need to fully take advantage of. That doesn't mean there aren't gaps. It doesn't mean there aren't things that need to modernize and get better at. There absolutely are. Last I heard, they're ahead of schedule with the NRC design review, or I'm sorry, the new scale design review. That's great. But there's still some gaps. They're still asking some questions they may not need to. But I think we're seeing the right leadership to come together at the commission right now at this time, that we can really take advantage of that and move the needle forward in a significant way to get the NRC to a much better position to take advantage of what they offer. And finally, I think in light of all of this, the way I like to think about this, and part of the motivation for why we started Oklo, was we really do control our own destiny. It's not waiting for some policymaker or some environmental group or someone else to do something, or someone pick us up, carry us to the goal line, or hold our hand. We get to control our own destiny. I think there's an often tendency to say, just like what you said, Eric, about what Warren Neyer's key to the atomic bomb was, it's really not a secret. It's not some shortcut. It's really good engineering, hard work, and determination that get us to where we need to get. When there's problems, we have to engineer for them or around them, but we need to figure that out. And we need to shed this attitude that we cannot do things in this industry. And hopefully, what we're doing at Oklo and what our peer companies are doing can help break that mold and really start to show how things can work, which will, I think, stimulate and ignite a sort of a new wave of innovation, of building, of trying things that was reminiscent of what happened in the early stages of the nuclear era. And finally, I think one of the pieces that is, well, not finally, I should say, but one of the other pieces that is quite important as we think about how we interact, not just on the industry side, but also applies to universities and national labs, is to shed the risk aversion that we have. It's important to be able to try things. It's important to be able to fail at them. It's important to be able to move on. We can't be in the back seat and let lawyers drive things. We need to be in the front seat, driving things ourselves. You need that leadership to step up. And that's a challenge I think we all face. And I particularly leave that out there, to always strive to get better in terms of how we pursue and push forward the nuclear enterprise that was envisioned by Fermi. Because when you think about what that is, it's really just starting to take flight. It's a pretty young industry in light of others. And I think we're starting to realize what the potential can be on a global scale and fundamentally beyond. And that's one of the really neat things about this technology. It's not just based on yesterday or today. It's fundamentally what's going to drive us tomorrow. So thank you.